Okay, so let's graph one. Let's take a look at what it looks like. I already drew your graph for you, and whoa, look at that. There's the graph that we're about to draw. Interesting. We're going to graph the function y equals 4 to the x, and we're going to do it for the values of x from -2 to 2. Okay, so just make a little table off to the left there. We're going to evaluate this function from -2 to 2, and we're going to graph those points. Okay. So maybe it's easier to start at the bottom of this table because 4 to the power of 2 is a lot easier to calculate. So this would be 4 to the power of 2, which is just 16, right? 4 times 4. 4 to the power of 1 is 4. 4 to the power of 0.
0. Nope.
Anything to the power of 0? 1. Good, you guys know that. Here's maybe a little tricky one. 4 to the negative 1? 1 over 4, right? Negative exponents flip that, well, they don't flip it, but they relocate that base to the other side of the fraction.
So -2 would be 1 over 16?
Yeah. So 4 to the -2 would be 1 over 16. And you can see that if we kept going to -3, -4, -5, this value, the y value, is going to get very, 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 very small. Right? You'll have 4 to the -3 would be 1 over 64, okay, which is a very small value, and then 4 to the -4 is 1 over 256, I think. So it gets very, very tiny, very, very quick. Okay, so plotting some of these points, let's go 2 and 16, let's plot that guy. Okay, 2 over 16 up. Oops, let me get a bigger dot here. There we go, 2, 16. And then 1, 4. And then 0, 1. These are big dots. And then -1 and a quarter. Okay, that's going to be a little tough. -1 and a quarter would be like here. And then -2 and a 16th, which is really tiny.
Just put it like right on the line.
Well, I don't want to put it right on the line because that would mean it is on the line and it's not. Okay, so those are our 4 dots. And then we can connect them based on the behavior here that we see. Okay, so it'll come from infinity here, go through these dots, and then as it grows, oh great. It was going so good too. Let me try that again. As I move into the positive x, oh, I missed it again, man.
Third time is a charm.
Yes, got it. Okay. As I move into the positive x values, this guy grows really, really, really quickly. It gets steeper and steeper and steeper very quickly. And you can think about why that is, right? We have 4 to the power of 3, 4 to the power of 4, 4 to the power of 5. By the time you hit 4 to the power of 7, what do you have? What's 4 to the power of 7? Someone you just punch that out for me.
16,000.
There you go. So by the 7th x coordinate, with the positive 7th x coordinate, you're at 16,000, blah, 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 right? So they get really, really high, really, really quick, and really, really small, really, really quick. And it depends primarily on this value, how quickly or how slowly that growth happens. But does that make sense? Okay, so they're like crazy roller coasters that you want to, I don't know, only take your crazy friends on.
1 to the power of x is like this straight line.
1 to the power of x would be a flat line. Yeah, because 1 to the power of anything is still 1. Yeah, good question. Okay, so let's figure some more information out about this graph. What is the domain of our function up here? What is the domain? The x values. Just think about what kind of exponents I could put for 4. Are there any exponents that I'm not allowed to put?
No.
No, you could put anything. So the domain here is just all real numbers, right? Wow, set brackets are hard to do with a stylus. There we go. X such that x is a real number. Okay. All real x values, we're good to go. Range?
Anything above 0?
Anything above 0. Okay, let's think about that. Is there any way I could put a number for x and get a negative y value? Like 4 to the power of something equals a negative number. Is that possible? Maybe it's tempting to think that 4 to the power of negative something would give you a negative value. But we already saw that's not the case, right? 4 to the negative 1 give you a positive value, because all you're doing is relocating that base. And 4 to the negative 2 also give you a positive value. So it's impossible to generate negative values. Is it possible to generate 0? Can you raise 4 to the power of something and get 0? No, you cannot either. Right? You can get really, really close. You could put like 4 to the power of 1,000 and get a very, very, very tiny value, but it would not be 0. Okay, so our range goes for everything above 0, but not including 0, which should answer some of the questions that we have coming up. Okay, C asks, what is the x-intercept and the y-intercept? What's the x-intercept of this function? It doesn't have one. Why? It's never going to cross the x-axis. It's never going to hit y equals 0. Okay, so it doesn't have an x-intercept. What about the y-intercept? 1. Right, you can see that on the graph and on the table. Right there, it's 1. Okay. D, is the function increasing or decreasing? So if you're a little guy on a roller coaster cart here, I'll put it green here. So if you're a little guy on a roller coaster, I'm really bad at drawing roller coasters. Okay? And you're going from left to right. You're going this direction. Would you be going up or would you be going down? Up, obviously. Okay, so it's an increasing function.
But why did we start plotting right to left?
Just because it was a little easier to calculate 4 squared. I just started with that. You could go from the top down. That's fine. E asks the equation of the horizontal asymptote. What do you think? Where is the horizontal asymptote? 0? Be a little more specific. You mean like that, the point 0, or what do you mean? X equals 0 would be y equals 0. Good. Okay. X equals, sorry, now I'm saying it. Y equals 0 is this really poorly drawn green dotted line. There we go. And that is a horizontal asymptote. So as I go forever and ever and ever to the left, I will see this blue line get closer and closer and closer and closer to that green line, but it will never touch it, which is one of those strange paradoxes about math where you can forever get closer to something but never actually get there. Kind of like trying to ask out a very good-looking woman. You get like a really good relationship with them, and you feel like things are going well, and you're getting closer and closer and closer to each other.
Friend zone.
And you like try to ask her out, and she's like, "Oh, I just think we're friends. You're kind of like my brother. We're best friends." And right? Life. They eventually give in. I caught myself once. So, horizontal asymptote is y equals 0. Okay, that is the line, the horizontal line that the graph gets forever closer to but never actually touches. All right?